So this is a standard heat of formation question, and the question is, what is the enthalpy of formation of butane if the enthalpy of combustion is negative 2,876.9 kilojoules per mole? It also says something important that it gives you the state of water as a product. So water is liquid, and if it doesn't give you a balanced equation, you'll need to figure it out. So you'll have butane, oxygen producing CO2, and liquid water. States are important in these types of questions. And once it's balanced, it should look like that. The other piece of information you'll need are all the standard heats of formation. Oxygen is in its natural state, of course, so it's going to be 0 kilojoules per mole. CO2, water in its liquid state. And what the question is being asked? The question being asked is the heat of formation, standard heat of formation of butane. It does give you the enthalpy of combustion of the entire reaction, so we've written that down as our given. So we continue with our formula. So delta H of the reaction given to us, we'll fill that in just a bit, is the sum, and for our coefficients, our molar coefficients. So it's going to be the sum of the delta H of formation of our products minus the sum, again, n for molar coefficients of the enthalpy of heat of formation of our reactants. Now we can start plugging things in. Before we start plugging values in, we'll look at the molar coefficients and then enthalpies of each of the first products minus the reactants. So 8 moles from the balanced equation as our first product, CO2. We'll have enthalpy of formation of CO2 in its gaseous state. 10 moles from our balanced equation of the enthalpy of formation of H2O in its liquid state. Here we will close brackets, square bracket, minus, now we're going to subtract our reactants. I'll just continue here. And this is what we don't know. 2 moles of butane gas, and I'm writing down the standard heat of formation of oxygen, knowing that it will eventually become a 0 and simplify this problem. Good. Now I can start filling these in. We have the heat of formation, or the enthalpy of the reaction, at negative 2,876.9 kilojoules. And here we'll just do fill in and do a bit of math in a bit. Fill in these values. Heat of formation of CO2. Heat of formation of liquid water. Don't forget your units. We can close these brackets, minus 2 moles heat of formation of butane. We don't have that value. I'll continue here, plus 13 mole, we know this value to be 0 kilojoules per mole. Good. We'll start to simplify this. So and with your calculator, you'll get these values. Then 10 times negative number, so minus 2858. Notice that mole cancels out. Maybe I should do that now. Mole cancels out. I'm not going to do that quite yet. Mole will cancel out as well. So we have kilojoules here. Close bracket, minus 2 moles, and we don't know our value. This is what the question is asking us for. And there we go. Now simplify. Just rewriting the heat of the reaction. After a bit of math, a bit of simplifying this, we get negative 6,006 kilojoules from our products on the left side, minus now 2 moles of our unknown, delta H of formation of butane. Right, a little bit of grade 8, grade 9 algebra, bring it over to the other side. Negative 6,006 kilojoules becomes positive 6,006, which you do to one side, you do to the other. I'm going to go ahead and simplify that now. And we're left with that. Now we're going to take away, or we're going to divide this out. What we do to one side, we do to the other. Notice this cancels out, and we're left with the units we want because this is a heat of formation of a mole of butane. So final answer, and that is the standard heat of formation per mole of butane.